Hi class, this is video 5, Introduction to Muscles, in which we'll talk about what we'll cover with each muscle that we cover in class. We'll talk about muscle terms, and we'll talk about the basics of how muscles work. So what we'll find is that if we understand the logic of the names and of how muscles work, that we can kind of relieve ourselves of a lot of unnecessary memorization, because we can just logic out what muscles do. You know, if we know where they attach, if we know what their name is, that kind of thing, we can figure out their actions. So let's dive right in and start out with talking about some key the basics about muscles, about how they work, which is a key thing to understand, so that we don't have to do all this memorization, so that every muscle just totally logically makes sense for us. Okay, so the first thing to know about muscles is that muscles create pulling forces. So always when a muscle is doing its action, it is pulling. And what that means for it to pull is that it's shortening. So in this video, we're not getting into the whole sliding filament theory, which is fascinating and really cool. But we need to just kind of have this awareness of how the muscle fibers shorten up, and the entire muscle shortens when it pulls, and when it does its action. So whenever a muscle is doing its action, it is pulling and it is shortening. And so when it does that shortening function, it's pulling on the two bones, or many muscles are attached to more than two bones, but let's pretend that they're attached to two bones to make it simpler in this explanation. They're pulling on the two bones that they're attached to. Typically, one bone is fixed and the other bone is moving. And so that fixed bone, the one that tends to be fixed, where it attaches to that bone, we will often call the origin of the muscle, and that is often the more proximal attachment. The end that tends to be moving, we will tend to call the insertion. That attachment site is called the insertion, and that tends to be the more distal attachment. So that's helpful in muscles that are on the extremities. Muscles in the trunk, sometimes it's a little harder to tell, you know, is this proximal, is this distal, because we don't use those terms, proximal and distal, within the trunk. But muscles will all have an origin and an insertion, but I do sort of use those terms kind of loosely. Basically, I want you to know where the muscles attach. I don't care so much if you know that this attachment is called the origin and this attachment is called the insertion. So back to our key points, though, about how muscles work. Number one, muscles shorten when they work. And so when they shorten, typically what a muscle does is it will shorten toward its center. So the whole thing gets shorter, which pulls the two bones together, the two bones that the muscle is attached to. So muscles' actions that we talk about are the movements that occur at the joints. So in order for a muscle to move a joint or to move a bone, and then that movement occurs at the joint, it has to be attached to that bone, and it has to cross that joint. So, I mean, these are very, very basic ideas, but if we're solid on these, then it can clear up a lot of future confusion about, you know, what actions a muscle might have. So muscles shorten when they do their work. They attach to bones. They pull those bones closer to each other when they're doing their actions. Those actions occur at joints. And so also remember, we're learning the attachment sites on the bones. So we're learning the names of the places on the bones where the muscles can attach, and we're learning the joints, and we're learning the movements that can happen at the joints. So so if we know that a muscle crosses the elbow joint, we know what actions the elbow joint can do, that helps us to figure out what actions that we can attribute to that muscle, right? So a muscle can't make an action happen at a joint where that action doesn't occur, where that movement doesn't occur. Okay, so where a muscle crosses a joint determines how it moves that joint. So some joints are really simple, right? Like a hinge joint, like the elbow, or like the interphalangeal joints are hinge joints, and all they do is flexion and extension. But they're a good example for us to look at. So if a muscle crosses the elbow on the anterior side, when that muscle shortens and pulls the bones closer together, is going to create flexion. That's the action that's going to happen at the elbow. If a muscle crosses the elbow on the posterior side, when it shortens and pulls the bones, its attachment sites closer to each other, it's going to create extension. That will be the action that it will do. So hinge joints are pretty easy, right? Because there's only two actions that can happen there. More complicated joints like the shoulder or the hip or the spine, where more movements happen, this still holds true. So take the shoulder, for example. If a muscle crosses the shoulder on the anterior side and it shortens and pulls its two attachment sites closer to each other, it's going to create flexion in the shoulder. If it crosses laterally, so it's going laterally over the shoulder joint, when it shortens and pulls its two attachment sites to each other, it's going to do abduction, right? So we're pulling this point closer to this point. When we do that, abduction happens. If a muscle crosses a joint on the posterior aspect, and it pulls and shortens, then that action, the action that muscle will do is extension. So if a muscle crosses a joint on the medial side, then when it pulls and shortens, it's going to do adduction. Okay, so flexion, extension, adduction, abduction, those all are movements that we've talked about. And so where a muscle is placed, like what direction it crosses a joint at, will determine which of those actions a muscle can carry out. Rotation, medial rotation, lateral rotation, the muscle has to be placed appropriately. It has to cross the joint in the right direction and have its fibers run in the right direction in order to create those movements. So hopefully that's pretty straightforward. Let's see. So muscles pull, they shorten when they do their work. They attach to bones. Movement occurs at joints. So a muscle has to cross a joint to be able to create a movement at that joint. At the side of the joint that the muscle crosses on determines the action that muscle has at that joint. And so we can use all of that to help to figure out how muscles are working. So let's define a few terms that we're going to use when we talk about movements and the actions that muscles do. So the first term is concentric contraction. So you probably have heard that term before. A concentric contraction, the term concentric means to the center. So a concentric contraction is a contraction that occurs when the muscle is shortening to its own center. That's the most common type of contraction that there is. And those are a lot those are essentially the actions that we're going to be looking at. Now a concentric contraction, so here, this is a concentric contraction. So biceps brachii crosses the elbow joint. It's pulling on its attachment here, distal to the elbow joint, and creating this movement, and it's concentrically contracting. So the muscle fibers are moving, the whole muscle is shortening toward its own center to create that action. That's a concentric contraction. Now there are also eccentric contractions. So eccentric contractions are when a muscle is contracting, so it's attempting to shorten, because that's the only thing really that muscles can do is shorten. So it's attempting to shorten, but it's basically it is allowing a lengthening to happen while it's attempting to shorten, if that makes any sense. So here's an example. So let's say that I had a weight in my hand. Okay, I have a weight in my hand. So concentric contraction, the muscle is shortening and I'm pulling the two bones closer to each other. Now if I wanted to lower the weight slowly, this is an eccentric contraction. So the same muscle is working, but is working with just enough force to slowly lower the weight and is actually getting longer. So it kind of like it started in its shortest position, and then it kind of releases and it releases and it releases and it releases, but it's still, in a sense, attempting to shorten, but it's allowing these releases to happen. That's an eccentric contraction. Okay, so concentric contraction, the muscle shortens toward its center. Eccentric contraction, the muscle is still pulling, but it's allowing these releases, and so it's getting longer as the as the movement occurs. The example in the book is a great example. So you can pick up a glass of water to take a drink. When you put it down, you can't just let gravity take it, because like maybe the glass would break when it hits the table. So you need to lower it slowly enough. So you need to control the descent of the glass so that it doesn't break, and to control that descent, you're doing an eccentric contraction. There are also isometric contractions. So isometric means same length, meaning it's a contraction that happens but no movement occurs. So the muscle does not change in length when that contraction occurs. So there's a couple of things that can create a concentric contraction. One could be you're just holding a weight, and basically the muscle that's exerting the force is just using enough force to counter gravity, the pull of gravity on the weight. It's not using enough to create a concentric contraction. Okay, so that's an isometric contraction, where the muscle just stays at the same length because it is just working hard enough to oppose gravity and not working hard enough, not exerting enough force to move the weight. Another example of an isometric contraction is when, so we'll talk about it in a minute, muscles work in pairs. So in the example in the arm, biceps and triceps. So biceps brachii on the anterior upper arm, triceps brachii on the posterior upper arm. They oppose each other. They have opposite actions, and we'll get a term for that in just a minute. But if they are working with equal force, then we get no movement. So biceps is trying to contract and trying to flex the elbow. At the same time, triceps is trying to contract and extend the elbow. If they're working with the same amount of force, then the elbow doesn't go anywhere. Both muscles are working. That's an isometric contraction. Okay, what other terms do we need to define here? Open chain and closed chain movements. And we did already talk about origin and insertion, but let me talk about origin and insertion, and then we'll move to the gym and look at open chain and closed chain movements. So origin and insertion I mentioned earlier, but just to define those, again, an origin of a muscle is the place where it attaches to a bone, where when that's the bone that tends not to move as much in an action. So like, for instance, in biceps brachii, we're not going to get into the specific attachments, but when I do this action, biceps is working, but there's a stable end and there's a moving end of the muscle. So the moving end is down here, so the forearm moves as a result of the contraction. The upper arm stays still. So the origin of a muscle we tend to call the attachment site the origin when it's the end of the muscle that tends to be stabilized during a movement, and then the insertion is the end that tends to move during a movement. But what we're about to see in open chain and closed chain movements is that really a muscle can pull. It can pull on either end. It can be stable on either end, which begins to make learning anatomy a little more complicated. But this is an important concept to understand, because when we learn anatomy, we can go, oh, deltoid does abduction, deltoid does shoulder flexion, and that's helpful. But is anybody going to come to you and say, oh, I was at home today doing shoulder flexion like this and I injured my deltoid? No, they're doing more complex movements. They're like maybe moving their body around. They're moving with lots of muscles all at once. So we need to understand how muscles work together, and we also need to understand ways that muscles move the body when the insertion is fixed and the origin is the moving end. So let's move to the gym and take a look at a couple of examples of open and closed chain movements. Okay, so an open chain movement and a closed chain movement. What are those? So an open chain movement is also, in the book, it's also referred to as the standard action movements, or the standard movements, or something. Standard is what it's called. So those are the movements where it especially applies to the extremities, where the distal end is freely moving in the air. Okay, so this is an open, anything I do where my arm is moving around, that's an open chain movement. So even if I'm bearing weight with that arm, that's an open chain movement. If the distal end is fixed, however, then that turns into a closed chain action. So open chain, so let's go back to biceps brachii. Open chain we get, it does elbow flexion, whether it's an open chain movement or a closed chain movement, right? So elbow flexion happens when biceps brachii contracts. But this is elbow flexion happening as an open chain movement where the forearm is moving and the upper arm is fixed. Now let's look at the same movement, so it's still elbow flexion, but let's fix the forearm and move the upper arm. So what does that look like? So here we're going to fix the forearm, it will stay put, and we'll move the upper arm, but we're still doing elbow flexion. So it's the same movement, but this is closed chain. So biceps brachii still does elbow flexion, but if the distal part of the muscle is fixed and the proximal part ends, we're going to call that a closed chain movement or a reverse action movement, which is also what it's called in the book. So as we go through and learn muscles, you'll see with each one, sometimes I'll have you just learn the standard actions, and sometimes I'll have you learn some of the reverse actions also. It depends on how commonly some of the reverse actions happen, and how commonly those reverse actions show up, like in muscle injury and that kind of thing. Let's look at some examples of open and closed chain in the lower body. So in the lower body, it's unless you're like, say you're swimming in a pool, then the foot is moving freely, and we would have open chain actions happening. But when we're walking around, the lower extremity it's common for it to have closed chain movements happening, right? So if I'm walking, the foot that's planted is always doing a closed chain, that whole leg is doing closed chain movements, but the leg that's stepping through, while it's in the air, it's doing open chain movements, okay? So we're doing open and closed chain movements all the time in the legs. So if we're moving our body around, we're walking, we're running, or whatever, there will be some closed chain movements happening when the foot is on the ground and creating some movement, and open chain when the foot is not on the ground. And so we can also, like, say if we lift the legs, right? So now the legs are in the air, so that would be an open chain movement. And if I was doing hip flexion. So if I do hip flexion as a closed chain, it would look like this. The distal end is fixed, and I'm moving the proximal end, okay? So that's open chain and closed chain, or standard actions and reverse actions, all of which are important and applicable when we're learning muscles. When we first start out with learning muscles, though, we're going to try and focus a little bit more on the standard actions, and little by little we'll be kind of feeding in some of those closed chain actions to kind of mix it up a little bit and give us a full picture of what certain muscles do. Okay, so let's go back and talk then about our what we're going to learn with each muscle that we're going to study, and then we have a few more terms to define also. Okay, so as we go through and learn each of the muscles that we're going to be talking about, which is the vast majority of the muscles in the body, but not every single muscle in the body. For each muscle we study, we're going to learn the name of the muscle, and as we cover each muscle, we need to try to get as much information as we can out of each of these pieces that we're studying. So first thing is the name of the muscle, and oftentimes the name of the muscle tells us a lot about the muscle. It might tell us its location, like biceps brachii. Biceps means it refers to upper arm, so we know that that's the location of that muscle. And other things we can find out from the name, like, again, biceps brachii. Did I say biceps meant upper arm? Brachii refers to upper arm. Biceps means two heads. So it means that there are two bellies of that muscle. So that tells you something about that muscle. The name tells you where it is, and it tells you something about what it looks like. So we'll learn the name of every muscle, and we'll try to figure out something about the name. So again, it might tell us what the muscle looks like. It might tell us what actions the muscle has. It might tell us where the muscle is, that sort of thing. So we'll learn the name. We'll learn the general location, so that when you are looking at muscles on a diagram or palpating muscles on a model or on yourself, you know basically where that muscle is. So the deltoid is here, the biceps brachii is here, deep to it is brachialis, triceps brachii is on the posterior arm. So a general idea of the location of the muscles that you would be able to indicate on a diagram. But then that general location of the muscle tells us more about the muscle, right? So if we can visualize where the muscle is, then we can also visualize what joints that muscle crosses, what joint or joints it crosses, and where it crosses that joint. So does it cross anteriorly? Does it cross laterally? Does it cross medially? Does it cross posteriorly? And so that's going to give us really good information also about how it can move that joint. And then we will also cover the actions. And so some of the actions, for most muscles, we'll talk about most of the standard actions. There might be some of those standard actions we'll leave out sometimes. And then for some muscles, we'll also talk about some of the reverse actions as well. So the open chain reaction, open chain actions and the movements and the closed chain movements. But you should, if you know the name of the muscle, you know the general location, you know the joint that it crosses, you know where and how it crosses that joint, you're going to be able to figure out a lot of those actions on your own. But then we will make sure, we'll go through and talk about each of the actions and make sure that those make sense and that you can visualize those actions happening. And then, so your book gives you 5 steps to in learning muscles. And so I just outlined the first 3. The 4th step is memorizing attachments and actions if necessary. So if you being able to visualize the muscle and know the general location and the name isn't enough, which in some cases that's enough to kind of know what the actions are. Sometimes you do need to more specifically memorize the attachment sites, and also sometimes you need to memorize the actions. So that would be the next step, is making sure that you kind of have the details of the attachment sites and the actions down. And then the last piece of learning muscles is understanding the relationship that muscle has to other muscles, which leads us into our last set of terms that we need to have down before we dive into learning muscles. So for instance, some muscles are superficial to other muscles, some muscles are deep to other muscles, so we need to understand that relationship that muscles have to each other. Is it a big muscle that does a lot of the movement? Is it a small muscle that maybe does more stabilizing or something like that? So those sorts of things we need to discern. And does the muscle work as a group, with other muscles in a group? So let's look at some of these terms that are terms that we will assign to some muscles as we're learning them, and terms that we'll use to talk about muscles with each other, like to compare and contrast them and that sort of thing. So our first term is prime mover. So the prime mover is the strongest muscle in a given action. And so that's often important to know, because very often it's the prime mover that gets injured if an action is happening. Usually that will tend to happen if the muscle is fatigued and has done an action a lot and then takes a break and then it does that action some more, or it has sort of started resting and then we're going to ask it to do that some more, then that muscle may get injured from something like that. So, but that doesn't have anything to do with the fact that it does have to do with the fact that it's the prime mover, but the term prime mover simply refers to the fact that a muscle that we'll call the prime mover is the main or the strongest muscle in a given action. Another term is agonist, which is synonymous with mover. So whenever we're talking about a muscle, we'll talk about, we'll focus on a muscle, right? And whatever muscle we're focusing on, that's the agonist. And then we can compare other muscles to it. So agonist or mover, or basically like the subject, right? It's the muscle that we're talking about. Then once we've determined what muscle is the agonist, then we can talk about other things like what muscles are synergists. So that's another term, synergist. So 2 muscles are synergistic to each other if they share the same action at the same joint. So biceps brachii and brachialis, for instance, are 2 upper arm muscles that are synergists. They both do elbow flexion. Okay, so synergists are muscles that share the same action. And then another term is antagonist. So if the agonist does one action, and we're talking about an action that, we're talking about a muscle that does an opposite action, that muscle would be called an antagonist. And muscles exist in antagonistic pairs, and that doesn't mean that they fight each other necessarily. They actually, will often work together to stabilize a part of the body. But antagonistic muscles do opposite actions. So, for instance, biceps brachii does elbow flexion, triceps brachii does elbow extension. They are antagonists to each other. And then two other terms, unilateral action. So these last two terms, unilateral action and bilateral action, those are terms that we use to refer to muscles that are on the torso, on the trunk. So like neck and chest and abdomen and back muscles. So those are muscles that there is a right and left muscle. So like trapezius, the upper back muscle. There's a right trapezius and a left trapezius. And so there are actions that trapezius might carry out at times when only the right trapezius is working. And if that's the case, we'll call those unilateral actions. So unilateral, uni means one and lateral means side. So they're one-sided actions, unilateral actions. Whereas if there's an action that happens when both sides of trapezius, so the right and the left trapezius are working together, we'll call those bilateral actions. So bilateral means, bi means two, lateral means side. So bilateral actions are when both sides are working together. And so as we learn muscle actions, sometimes we'll learn whether an action is a unilateral action or a bilateral action. Okay, so that's it for terms that we need and basic ideas that we need to learn muscles. So our next step here now is to dive in and start looking at some of our first muscles. So we'll look at deltoid, latissimus dorsi, trapezius, and teres major. So I realize I neglected to give you a word because I was distracted at the end of video 4 by our dog Brady knocking over the camera. So the response word for video 4 is Brady, and the response word for video 5, this one, is loves. Okay, so Brady loves something is going to be the response word for video 6. So Brady loves, those are our first two response words. And let me know if you have any questions about homework. There is not specific homework for video 5, just for 4 and for 6, I think. Let me consult. Yes, there is not specific video 5 homework. I just want you to have this basic information. If you have questions about this, let me know, and I'll try and clarify those during class time. And other than that, let's move on to video 6 and start diving into muscles.